All right, we've talked about proportional relationships the last couple lessons, and now we're going to talk about solving proportions. So when we have missing parts in relationships that we know are proportional, what strategies can we use to solve them? So a proportion is an equation that states that two ratios are equal. So I've got some examples here of some proportions. It's basically just two equal fractions or two equal ratios. That makes a proportion. So I've got examples here of 2/3 equals 8/12. 12/21 equals 4/7, 1/2 equals 3/6, and 6/8 equals 9/12. So these are equal ratios. They are proportions. So what we're going to be doing is solving proportions, meaning there's a missing part in the proportion, and we need to find the value in that proportion. So I've got 9 proportions here. So if you could pause the video and see how many of these proportions you could figure out before you continue, please go ahead and do that and try to remember what strategies you use to find the missing part of the proportion. Okay, go ahead and pause and do that now. Okay, how many of these were you able to solve, and how did you solve them? Well, I'm going to go through these, and I'm going to try to guess maybe how you figured these out. In common ways to solve this one here, 4/5 is how many 20ths? Well, I'm guessing maybe a common strategy here was you noticed that 20 was 5 times 4, or 4 times bigger. That relationship has to be the same in the numerator as well. So the numerator in the right-hand ratio has to be 4 times bigger than the numerator in the left as well. And 4 times 4 is 16, so x equals 16. Did you solve that? And is that how you solved it? Maybe, maybe not. Let's take a look at the next one. Similar strategy here. I know that in the numerators here, there's a nice relationship. 7 times 5 is 35. That relationship must exist in the denominator as well. So 9 times 5 is going to tell me what my denominator is, and 9 times 5 is 45. So 7/9 is equal to 35/45. Again, in the next ratio here, I see there's a nice relationship in the denominators again. 15 divided by 5 is 3, and that same relationship must exist in the numerator. So 10 divided by 5 is 2. So 2/3 equals 10/15. Okay, that is a pretty common way to solve proportions here. And here we're looking horizontally, numerator to numerator or denominator to denominator. So this is a nice horizontal relationship here, or between the ratios. We're looking for a relationship between them from one ratio to another. The next row, that strategy kind of falls apart a little bit. If I'm trying to look at a relationship between the 2 and the 5, for example here, it's not really a very nice relationship, but you may notice there is a much nicer relationship vertically, or within the ratio 2/6. The denominator is 3 times bigger than the numerator. That same relationship must exist in the other ratio as well. So I know that this denominator has to be 3 times bigger than its numerator, so that would make it 15. So 2/6 is equivalent to 5/15. And again, in the next proportion, 3/18 is equal to 7/x. Again, horizontally, between the ratios here, 3 and 7 aren't really friendly numbers to work with, but we do notice that there's a nice relationship vertically from the numerator to the denominator again is 6 times bigger. 3 times 6 is 18. That same relationship must exist in the other ratio. So 7 times 6 would tell me what this denominator has to be, and that's 42. So 3/18 is equivalent to 7/42. And again, in the next one, we have the same issue. 12 and 16 horizontally don't really play nice together, not as nicely as 4 and 16 do. And we notice, oh, actually, I'm going to go the other way on this. Vertically, here we have a nice relationship. 16 divided by 4 is 4. So that, again, same relationship must exist in the other ratio. 12 divided by 4 will tell me what my numerator is, and that's going to be 3. So x is equal to 3. So 3/12 is equal to 4/16. Have you solved all of these so far, and is that the strategy you used? So now we've got two different things to look for in a proportion to be able to solve it. In the top row in blue, we were looking horizontally, or between the ratios. In the middle row, we were looking vertically within the ratios to look for relationships. Now, these bottom proportions are a little bit more challenging. If we look horizontally, there isn't really good relationships. And if we look vertically, there isn't really good, easy relationships to do. So, are we stuck? How do we solve a proportion where a vertical or a horizontal relationship doesn't really exist that well? Well, if we notice something, we can use it to help us solve these proportions, and we're going to use what we call cross products. You may have heard them before. We notice that if you multiply across a proportion and find the product here, the numerator of one times the denominator of another, 20 times 4 here is 80, and 5 times 16 is 80. Looking at the next one, 9 times 35 is 315, and 7 times 45 is 315. In the next one, 3 times 10 is 30, and 15 times 2 is 30. In the next one, again, we have a cross product here. 6 times 5 is 30. 15 times 2 is 30. 42 times 3 is 126. 18 times 7 is 126. 12 times 4 is 48. 16 times 3 is 48. We notice that these products, these cross products, are always the same in a proportion. We can use that fact to help us solve these types of proportions where vertical and horizontal relationships don't particularly exist. So if we know that the cross products are equal, I can take 14 times 5, and that's 70. That tells me that 6 times x has to be what? 6 times x has to be 70. Well, 6 times what gives you 70? I would take 70 divided by 6 to find out. And 70 divided by 6 is 11.6 repeating. So there we've solved it. X is 11.6 repeating. So here we get kind of a complex fraction. We're going to get a fraction within a fraction with these, and that's okay because we have learned about complex fractions before. The next ratio, or the next proportion, I know that this cross product is 90. So I know that this cross product also has to be 90. 13 times x has to be 90. So 90 divided by 13 is going to tell me what x is. And 90 divided by 13 is 6.923, and that goes on and on and on. So about 16.9 is x, solved using the cross products. And then finally, I know this cross product, 8 times 12, is 96. So I know that 7 times x also has to be 96. Well, 7 times what gives me 96? 96 divided by 7 will tell me what x is. And 96 divided by 7 is 13.714, so on and so forth. So about 13.7 if I round that to the nearest tenth. So now we have what we call cross products, and that's the numerator of one ratio times the denominator of the other ratio in a proportion. And we know now that this is the take-home fact for the day. The cross products of a proportion are equal. So whenever we have a proportion, I know that A times D is going to equal B times C. These two products are always equal. So now we actually have 3 strategies for solving a proportion. We're going to either look for horizontal relationships between the ratios, vertical relationships within the ratios, or cross products. Use the cross products and the fact that the cross products are equal to help us solve the proportion. So let's apply that to these 4 proportions here. Which strategy would you use to solve them? Now might be a good time to maybe pause the video and try to solve these on your own and see if you use the strategies that I use. All right, solving these proportions, again, all three strategies will work. It just depends on which one you find to be easiest. So looking at this proportion here, this kind of jumps out at me. I don't know if you noticed this, but 20 divided by 5 is 4. So I've got a between ratios relationship here, a horizontal relationship here. So to solve this, I can take 7 divided by 5. And if I take 7 divided by 5, I get 1.4. So x is 1.4 in this proportion. The next one, I see a vertical relationship here. 7/14 is 1/2. So the numerator is half of the denominator, or the denominator divided by 2. So if I just take 12 divided by 2, that's going to tell me what C is. So C is 6. I've solved that proportion. So I used a horizontal relationship there. I used a vertical relationship in the second one. The next one probably used cross products. There is a horizontal relationship here, but it's kind of harder to see. Usually when decimals appear in our proportions, we kind of default to the cross products. So we'll go ahead and use the cross products here. 50 times 6.8 is 340. So that means T times 34 has to be 340 as well. Well, 10 times 34 is 340, so I know T is 10. And then finally, again, here there is a horizontal relationship here, but again, a decimal is present, so probably use the cross products. 8.5 times 42 is 357. That means 51 times m has to be 357 as well. So 357 divided by 51 will tell me what m is, and that gives me 7 when I divide that. So there we have solved these proportions using combinations of either horizontal relationships, vertical relationships, or cross products using those three strategies. So here Cindy paid $34.60 for 4 tickets to a movie. How much would it cost for 7 tickets? So again, we have a proportional relationship here because the cost of the tickets is always the same. There's actually 2 strategies for solving these types of word problems. We can use a proportion, or we can go back to that constant of proportionality, that unit rate. So I'm going to solve this twice to show you 2 different ways to solve this, and then I'll let you pick which one you think was more efficient. I can use a proportion because I know that it's $34.60 for 4 tickets. That has to be equal to how much money for 7 tickets. So here we have a proportion, not a nice vertical or horizontal relationship here. So we can use the cross product to solve this. 7 times $34.60 is 242.2. So this cross product also has to be 242.2. So 242.2 divided by 4 gives me 60.55. So it would cost $60.55 for 7 tickets. Or I can use that unit rate. How much does it cost for just 1 ticket? If it's $34.60 for 4 tickets, that's a unit rate of $8.65 per ticket. Now I can use that unit rate to scale that up to 7 tickets. So if I take $8.75 times 7, I get $60.55 for 7 tickets. So again, same solution, 2 different strategies to do that, using proportions or using unit rates. So we're kind of tying those ideas together that we have been talking about, that unit rate, that constant rate of change, and how that ties into proportions and proportional relationships.